Okay, good evening. I'm Dr. Reggie Taylor, and I'm from the Office of Research and Doctoral Services. And this evening, I will be facilitating a session on multiple linear regression. If anyone attended any of the previous sessions, I think last week I did a session on bivariate regression, and this session here is just an extension of bivariate regression. So kind of going in some progressive order here, for lack of better words. And so what are we aiming to do here this evening? First of all, my concern is more so not necessarily having you leave this session here in 45 minutes to an hour and saying you're a linear regression expert. No, that's not going to happen. I've taken linear regression courses that were 16, 18 weeks. And so it's no way that we're going to try to become regression experts. But I want to ease your anxiety about multiple regression, and statistical concepts, in general. Ease your anxiety when you hear the term, when you see the term, or perhaps you're asked to, perform or conduct a multiple linear regression test, that there's, minimum anxiety and you have some kind of idea, of what it is that you are going to do, okay? And we want to make sure that you have a broad overview. And again, broad overview of concepts and applications. In other words, you should know under what conditions, you would conduct a multiple linear regression test versus, say, another type of test. This is important, as you read journal articles and, you read about these different statistical tests, what are the conditions? Why did this author do one test, and another author did another test? So it's important to understand those broad concepts. Then we'll focus on how to conduct the multiple linear regression test in SPSS. Now, we're not going to spend a lot of time in SPSS and clicking on a lot of buttons, because one of the most important things that we're concerned with is the output, how to interpret what it is in the context of that research question or those variables, that we are looking for that relationship in, okay? And then I'll provide you with some additional resources to move forward. And then ask you and invite you to complete an anonymous survey at the end of this session. So how will we get to those objectives? First of all, I'm going to review the scales of measurement. When you got the invitation, you saw that it mentioned that there would be a review of the scales of measurement, because that's so vital and so important, to understand any statistical analysis. As a matter of fact, I personally think this is one of the most important concepts to understand in statistics, specifically statistical analysis. And you'll see why I think so. And then we'll get right into multiple linear regression. Why do we use it? And then we're going to talk just briefly about data assumptions. And the reason I say briefly is because I have done this session several times before, and the data assumptions section can take up, an hour or more so itself. And so it takes a session like this where we're going into 2.5 hours. And we know that that's not productive, because, we'll lose our focus at a certain point. But there are previous seminars that I have conducted on multiple linear regression where I did go through the entire review of the data assumptions, and you will be forwarded that link. So basically, when you need to focus on the data assumptions, I'll send you the link and you'll click on that link. And when that video gets to the data assumptions, that would kind of like fill in what I'm not going to take another hour or so here to do tonight, if that makes sense, okay? We'll look at the procedure of doing it, and then more important, the output. What does it mean? Did I just answer my research question? How did I answer my research question? And more so, even if I'm looking at a journal article, and that author has presented the SPSS output, do I understand perhaps the most important component of an article? What were the results? It makes no sense to read a journal article where okay, this author used this theory and they did this test, and then you have no idea of what really the results and the findings were, in the context of the study. So that's very important, to understand the output when we see it. And more important, when we conduct multiple linear regression, it's important to know how to present the write-ups ourselves, to accurately present the results of our research. And that's where we're going to focus on the output interpretations and the APA results write-ups. So again, when you see multiple regression, hopefully that anxiety is eased and you kind of have a better understanding of what you are looking at. Again, I'll point you to some quantitative resources. We'll summarize, and then here's the link to the anonymous survey that I would appreciate if you would take, okay? So what are we talking about when we talk about multiple linear regression? We hear the names of all these tests: multiple regression, t-test, ANOVA, MANOVA. What's the difference in them? Why would I choose one versus the other, et cetera, et cetera? And that's very important to understand. Now, if I could ask, as I usually do in these sessions, if you're willing to, could you please just type in the chat the reason that you are here at this session? And for example, are you in the dissertation phase and you are conducting multiple linear regression? Are you not quite sure what test? Are you taking a course? Is this an application assignment? Or are you just taking this for general, professional and personal development? That information would be very helpful to me and may help Taylor. So if you could just perhaps type in the chat, personal development. Okay, thank you, Joshua. Fantastic. Dissertation, coursework. Okay, so there's something for everyone in this session. Assignment. Okay, fantastic. Suggested by instructor. Fantastic. Okay. Fantastic. I think that we have reached the right audience here. Now, when we are conducting multiple linear regression, what we're trying to do is predict something. Keep the word in mind, predict. Because not all statistical tests are designed and developed to predict things, okay? You're trying to predict something, and what you're trying to do is predict the value of a variable, and that variable is called the dependent variable. Now, what's important is that dependent variable, and this is where we're going to have the brief discussion on the scales of measurement, because I'll give you another resource that goes in depth. It has to be a scale variable, and what do we mean by that? There's 4 scales of measurement: nominal, ordinal, interval, and ratio. So for example, on one extreme, we have what's called the nominal variable, and that's, say, for example, gender. You're collecting data, and gender is a piece of information that you're collecting, male or female, or perhaps non-binary. That's categorical. But suppose you are collecting data and it's numerical. The score is on on an achievement test, a GPA score, a numerical value, this interval or ratio. If you're trying to predict that type of a number and you have 2 or more predictor variables, then multiple linear regression is the appropriate analysis. And again, it's used to answer predictive research questions. And we'll see exactly what we mean by predictive as we come to the end of this session. And because there's going to be something that I'm going to show you called the regression equation. And this will make all of this stuff make sense. So for example, we have a question down here in the last bullet. What is the relationship between, and I have self-esteem, which I'm using as one variable. And in this case, I'm saying life satisfaction. That's another variable, and perceived stress. Now, I'm going to take perceived stress, and I'm going to make that a different color purposely. Now, the word "and" in a research question, specifically and especially for multiple regression or relationship type study, that word "and" is very critical. And the placement of that word is very critical. And the placement of these variables that I have just highlighted is critical. That word "and" separates to the left of it in red predictor variables. So you can clearly see in this example that you have two predictor variables, self-esteem, life satisfaction. The word and denotes that now your dependent variable is coming, and that is perceived stress. So you are trying to predict perceived stress in this example from one's level of self-esteem, their life satisfaction. So obviously you would be collecting this data and you would be getting a self-esteem score, a life satisfaction score, and a perceived stress score for each individual. Now, if you are, say, doing an assignment and someone gives you a data set, then you are going to select at least two predictive variables in that data set and one dependent variable, okay? And remember that that dependent variable should be a scale or numerical variable, okay? Now, just going to talk about that a little bit more. And here's a slide for you. Again, the relationship between X1, X2, and Y. And X1 and X2 are predictors. Now, with multiple regression, remember, you can go X1, X2, X3, X4, X5, etc. That's why it's called multiple regression. You can have multiple predictor variables or multiple X's, as we have here. And then the dependent variable. Again, the word and separates. And the reason this is important, because especially when I'm looking at a lot of research and reviewing a lot of research, these variables are kind of flip-flopped and they're just put in any kind of order. So anyone now that's trying to review research, we really don't know what is the dependent variable. And the only thing that I can surmise is that that dependent variable is that word that comes after the word and. But that may not be your intention. You just may be just listing variables. So that's very critical to understand, okay? Is everybody okay with that? Everybody understand that? Can I get some confirmation before I move on? Because that's very important. And we'll see that later on as we are actually looking at results and findings and interpreting output. So remember that temporal order of a research question. Now, when I talk about regression, I'm talking about residuals. It's all about the residuals. What does Dr. Taylor mean about it's all about the residuals? And most people really never discuss regression in this format. And again, we really don't understand what we've done when we are done. But what we have done is that we have talked a lot about residuals. What are residuals? Excuse me. Okay, we're going to do a little quick exercise. Now, I have a number that I have in my head. I'm actually now writing it down on a piece of paper, and it's from 1 to 10. Okay? Now, what I'd like for you to do is to be a psychic. And you're going to try to predict or guess this number. Okay? You're trying to predict or guess this number that I have in my head. Okay? From 1 to 10. You're trying to predict that number. Now, when you put your number in the chat, if you can, go ahead and start typing in your numbers, please. I'd just like to see what we get. Okay. All right. Okay, we have enough. All righty. It's like playing, what's that one game, the Price is Right or something of that nature? Now, the number that I have in my head and I've written down is, you can see, is a 4. Okay? Now, you're trying to guess my number, and obviously you want to get as close to my number as possible, right? Suppose I was giving out a prize. Now, take the difference between the two numbers. Don't worry about negatives and positives, just the absolute value difference. And type that into the chat. So yes, exactly. That's the absolute difference. That second number that you have typed in the chat is called the residual. That is the difference between my number, the true value, and the guessed value. Okay, that's the difference between the observed value and the predicted value. Now, would you want a lower or a higher residual value if you're trying to predict a dependent variable? Logically, what would you want, a lower or a higher residual? Fantastic. Fantastic. Lower, of course. That is the concept of regression. Now, let's take this and put a little practical application into that. And always use the example of, let me see, I'm supposed to have a, some type of a board in here, whiteboard or something. Give me a second. Let me see. Okay. Okay. Let's take, for example, I'm going to just insert a new slide here. Just a regular old blank slide. Now, think about trying to predict hurricanes or weather. We know the weatherman, and we want that weather person to be as accurate as possible. I mean, it has implications. It has implications for traffic in the morning as we're moving about how we dress, etc. I mean, it has implications. It's important. And that's why the news is on every morning, and the weather is a big piece of that. Now, me living here in Northeast Florida, one of the things that we're always concerned with, are hurricanes during the hurricane season. Now, I'm going to attempt to do my best, excuse me, to kind of draw the US here, okay? And Florida being right down here in that little bottom right piece that's sticking out. Now, every morning we get up and the news is on and they're showing us something like this. Remember seeing something like this on the news, and those are called spaghetti plots. In each of these, you may hear your news person say the European model, this model, that model is predicting, and all of these are prediction lines. And notice they're not going in the same places, the same directions in some cases, kind of all in the general direction. But these are predictions of perhaps where that hurricane is going to hit, et cetera. And that's important to know. And so think of that, someone was doing a degree in weather or something, this could be a model of something that they could do multiple regression on, to predict certain things. In your field, what is it that's a problematic variable, a dependent variable, and what are you trying to use to predict that? What do you think predicts that? If you're just looking at a data set, go into that data set, look at the variables, the coded book of the variables, and now you're just kind of making up something in an application. You're saying, hey, okay, I'm going to use this as a dependent variable, and I'm going to try to predict it from this and that. Of course, the variables need to be numerical, okay? But that's an example. And so we want that model that's the closest predictor, or that one with the best or the lowest residual. Okay, does that make sense to everybody? The lowest residual value is what we are concerned with. Okay? And you're going to see now that we're going to start evaluating, residuals as we move forward in the regression process. Now, I'm going to briefly talk about assumptions, and then we'll move on. When we get into the section where I point you to other resources, you'll see that there are several other multiple linear regression seminars that I've done just like this, but I went through the whole assumption spiel, and that took us well into a couple of hours, and that's too much time to be spending, okay? But the point is that when you conduct a multiple linear regression test, as with any other parametric test, you have to be concerned with data assumptions. And what do I mean by data assumptions? These are characteristics about that data that if these characteristics are violated, or if the data doesn't meet these characteristics, this changes your conclusions. It changes your interpretations. As a matter of fact, we may not have any trust and any faith in the outputs. So we have to, in any statistical analysis, again, parametric tests, test assumptions. Now, when you collect data in research or have a data set or something, that data in 99% of the cases may not meet these assumptions. And that's fine. Because remember, these are mathematical models that the mathematicians went into their lab and said, we can predict something, but it's under very controlled conditions. The data has to be this, the data has to look like that. But again, we know that we're going to deviate from that. Now, that doesn't mean you have to recollect data or you have to resample data. No, it's just something that we have to do, and we'll talk about that. So first of all, we have to identify them. What are the assumptions for a multiple regression test? We would talk about that. Now, then we have to assess these assumptions, okay, prior to running the test. After the assessment, what were the results of the assumptions? Basically, did the data pass or fail? If the data fails, tell me what action you're going to take. Take the action. Now we basically clean the data up. Now you run the regression analysis. So this is a process that you would follow regardless of your statistical test, if that makes sense, okay? I'm going to briefly list what these 8 assumptions are, and we're not going to go in depth with them. But like, for example, I'm just going to point out, remember we said it should be an interval or ratio variable. You can't do this with categorical data. And that's a design thing. You just won't pick those variables. We must have a sufficient sample size. There must be a minimum number of cases or a minimum number of records, that we are reviewing, that we have to have, for our quantitative study. Okay. No significant outliers. We know that outliers wreak havoc, when we're doing prediction and correlation tests. And let me just give you an example to really help you understand these concepts. Let's just say that we were going to gather data on, say, the Apple Computer Company and its employees, and we are going to do some research. And one of the variables that we are going to collect is annual salary. Okay, annual salary. And we randomly sample, from the thousands and thousands of Apple employees, and we find out that the average salary, let's just say, is $50,000. I don't know, $50,000. But now, suppose that in that sample, we happen to get the CEO, Tim Cook. That $20 million salary is sitting in there with the 50s, the 40s, and the 30s. You can tell with even out anything that is going to significantly skew that data. So again, these are the types of things that we have to look at, and we call preliminary data analysis. Certain things like making sure none of the 2 variables, the predictor variables, are related to each other. That's like multicollinearity. Again, we need to make sure the data is linear. There's normality. But now, there's one thing that I want to point out. I see a lot of studies where individuals have addressed these assumptions. Or let me just say, taking a stab at addressing the assumptions. And what do I mean by that? Remember I said that it's all about the residuals. What the individuals are doing is that they are assessing linearity, but they are assessing linearity for the raw number. Remember your raw number that you put in when you guessed my number? Remember my raw true number that I put in? They're trying to see if there's a relationship, but it has to be the relationship between that second number that you put in, your residuals. Does that make sense? The residuals have to be normal, have to have normality. They need to be in a certain pattern. Does that make sense to everyone about what you are really, really analyzing and looking at when you are chatting, when you are assessing your assumptions? Does that make sense to everybody? I really want to make sure you understand that, okay? So basically, I want to know how linear is your guess, because we would want everybody's residuals to kind of be tight together, because that means we have a good model. Suppose the residuals were everywhere. We don't know where the hurricane's going to hit. So again, as long as you understand the concept of assumptions, you'll be great. But you'll see that in another session here that I'm going to give you the link to, that at your own leisure, you'll be able to see exactly how you test for each and every one of these assumptions. Okay? Now, let's say that we've tested for the assumptions and everything's good to go. So we'll assume that the data met all the assumptions. Now, what do we do? Well, now we go on and we run the regression analysis. Okay? So the first thing I'm going to do is I'm going to open up, let me see here. Let me see what's the best way to do this. What we'll do is that we're going to now look into SPSS, okay? And kind of just understand a data set. And so the first thing that I'm going to do now is just open up a data set. And just take a second now. Let's just look at this. Let's just familiarize ourselves with this. Ease our anxiety about a data set when all of this stuff pops up on the screen, okay? Now, what you see here is down at the bottom where my cursor is, and I'm going to be moving it around to make sure you see where it is. You see that I have different views. I have an overview tab, I have a data view tab, and I have a variable view tab, okay? Now I'm going to click into the variable view tab, and you see I get a different look here. And what this look here is actually how the data file is set up. Okay, this is not your raw data. But as you can see here, that I have variable names. Now, in this particular case, I have a variable, and we're going to call this variable here, excuse me, right here, variable number 2 is going to be called optimism, total optimism. And you can see it's labeled total optimism here. I have another variable called total life satisfaction. And you can see it's labeled total life satisfaction. And I have another variable here, total life self-esteem. And it's called total life self-esteem. So the other thing, remember when we talked about the scales of measurement? Notice that here, I'm going to bring the measure column over. Now look at this, total optimism. Remember I said the scale of measurement is important. When you click, you'll get a choice of scale, ordinal, or nominal. This is where, now let's just say you're doing this from a data set. You need to make sure that that data set that the variable that you select is a scale variable. And that's what I meant by the scales of measurement. So as you can see now, we're going to do some type of regression with these 3 variables here, and they all are scale or numerical values. So for example, we're going to predict the relations. We're going to see if 2 of these variables here, okay, 2 of these variables would be predictors, can predict, say, the 3rd variable. Okay? So, now, what happens in SPSS is that, and we'll get and do this live in SPSS, you're going to go into the analyze command, and then you'll see the regression, and then from regression, linear. Very simple. Analyze, regression, and linear, because we're doing multiple linear regression. From that, you'll get the linear regression box. And this is where, everything pretty much shows up that you're going to input to do the analysis. So what this is that the dependent variable is up here. Remember I said the dependent variable is that one that comes after the word and. Okay, you're going to take it from over here to the left and put it up in here. Okay, now we have two predictive variables because remember, this is multiple regression. So we have to have at least two predictors. So what we're doing is trying to predict perceived stress from self-esteem and satisfaction in this particular regression dialog box. Does everybody see that? Okay, and as a minimum, that's all that you would need to do for multiple linear regression. You don't need to pop in 4, 5, 6, 7, 8 predictive variables. You can, that's the beauty of regression, but it's not necessary. Now, versus what we did last time was bivariate regression, and the only thing that we had in there was perhaps a one predictor. That's bivariate, meaning two predictors altogether, stress and self-esteem. But then we change it to multiple regression, and we start adding additional predictive variables. We can start adding this variable in here. We can add this variable in here. Okay, does everybody understand that concept? Okay, fantastic. Now, from that, then the next thing that will pop up automatically for you would be something called the statistics. In other words, what are all the parameters and things that we want SPSS to spit out for us? In other words, what output now? Okay. And just follow this, but we always want the confidence intervals, the estimates. Make sure the confidence intervals are 95%. Model fit, the descriptive statistics. We always want to know the average score, the mean score, all those types of things. And remember when I talked about the assumptions, okay? Right here is where all of these things would be used to assess the assumptions down here, where we see the remember the residuals? Give me a second. Remember when we were going to assess the assumptions? And remember I said we assess residuals? Well, these are the boxes that would be checked, and it would produce output that would allow us to assess those assumptions. Does that make sense to everybody? I just wanted to show you that. This is one of the places where those assumptions, so really to assess a lot of these assumptions, all you're going to be doing is clicking the appropriate button, and then we need to know, okay, what is the Durbin-Watson going to tell me? What is the case-wide diagnosis going to tell me? And that should make sense to you, okay? Now, then there's a plot that you're going to produce, and we'll look at that, okay? And but that plot is then going to, after that, you're going to get output. This is where we want to focus. What does it mean? You'll see tables like this in journal articles. You'll see the authors writing this stuff up in statistical notation. What does it mean? We're going to look at that and understand what that means. So one of the first things that's going to come out is called the model summary, okay? And then the next piece of output is going to be something called the ANOVA table or the ANOVA output. All of this means something, believe it or not. And by the end of this session, you are going to be crystal clear with what all this means and how to write this up. Here's another piece of output called the coefficients. And you've seen all this output from SPSS and you look at it and you start scratching your head like, oh my gosh, what does all this mean? What am I supposed to do with this? That's where we're trying to get here so that we demystify that, okay? Now, let's take a look at that. Here is an example of regression output, okay? Remember I said there's going to be a model summary, there's going to be an ANOVA, and there's going to be a coefficient. Let's look at each of these individually. The first one that I'm going to focus on is the ANOVA. This is what addresses your research question. So for example, predictors. Is there a relationship between total life satisfaction, total self-esteem, and stress? The answer to that question is yes. Because in the ANOVA table, you'll look for the sig value. And we know from statistics that any model that is less than or equal to 0.05 is significant. Am I correct? We all recall that. So that's telling us that basically self-esteem, life satisfaction and self-esteem can predict total stress. Does everybody see that in the regression table? In the ANOVA table at this point? Everybody okay with that? If you were to look at an ANOVA table for a regression model, would you be able to tell me now, was that model significant or not? Okay, great. But now, look at this ANOVA model. And unfortunately, it tells me nothing about my predictor variables. We don't see anything in here about predictors, all these foreign words, right? So now what we have to do is that now we need to look further to understand the model. All of those variables that we're using as predictors. That's what we mean by model. So to look at that individual specificity, you're going to look into something called the coefficients table. Now what you'll see listed is the individual contributions of each variable. Does everybody see that? Okay, I'm going to hold off to make sure that everybody is following. Does everybody see that the individual contributions of each variable in the coefficients? Okay. Now, what does that mean? We always still have to go to our sig column. Now, tell me, was total self-esteem a significant contributor in this model? Fantastic. Yes, it was. What about total life satisfaction? Was it a significant contributor to the model? So what you have is a regression model. This is called the omnibus test, the overall test. And then this drills into all the predictors. If you had another variable, you'd have a line here with the same coefficients. If you had a fourth variable, you'd have another line here with the same coefficients, and you'd be looking in this sig column. Because in some cases, all of them may not be significant. Does everybody understand that? So some may be significant contributors, some may not. But you will determine that from the coefficients dialog box. Does everybody understand that? Okay, let's take it a step further now. Now, what's important here? Perhaps one of the most important pieces of output for the prediction piece is something called the unstandardized coefficients. Perhaps to me, the most important piece of information, misunderstood, never talked about, etc. What this is a beta, but basically it's called a slope. A slope. And we know that, let's put in another slide here. We know that when we plot data, remember this is from our Algebra 101, the data rises. So we may plot something and the data may look like that, right? That's the slope, how much it's rising for a unit increase. But some data may be like this. The slopes will change. This value here is the slope. Excuse me. Is the slope. So what does that mean? Okay, we're going to repeat this a couple of times. Total self-esteem. Remember now, we're trying to predict the dependent variable, which is perceived stress. What that slope is saying is for every 1 unit increase in total self-esteem. So let's just say we were measuring self-esteem from 1 to 50. I don't know. But this is basically saying for every 1 unit increase in self-esteem, the dependent variable is going to decrease by 0.480. You see the negative 0.480? Does everybody see that? So doesn't that make sense? That as, let's look at satisfaction, the same thing. What that's saying is that for every 1 unit increase in total life satisfaction, there will be a decrease in the dependent variable by 0.239. Does everybody see that? That is what that means. So now you can see that as total self-esteem and satisfaction rises or gets lower, perceived stress will change by a certain amount. Does everybody understand that? And now we're getting to being able to use these coefficients to predict. Okay? Now, let's even predict some values. Okay? Let's predict some values. And how will we do that? Let's take a look over here. Regression equation. How do we do that? What does this mean here? You see this constant? That's a slope, but you don't worry about that. That's not one of your predictors. That's kind of like the starting point. So we're trying to predict perceived stress. So we're going to start at 48.195. We know that's where we're going to start at. And we're going to go up or down from there, predicting our dependent variable. So does everybody here see 48.195? That's where I got that from, right there. Okay? Now I'm just going to follow the math. Minus 0.480. See that? Minus 0.480. But notice now I have the word self-esteem. Means that once I put a self-esteem score in there, the Y number is going to change. Once I put a life satisfaction score in there, now let's do this way here to even make it even more understandable. I am now going to do an example. I have an Excel file here where I have taken some coefficients. You see here, I'm trying to predict satisfaction, life satisfaction, the Y variable. Remember that constant value? I said, this is where we start at. Here's an example. And I have two slopes of optimism and self-esteem. So basically, this is saying, what is the relationship between optimism, self-esteem, and trying to predict life satisfaction? So we would think that as life optimism goes up, my self-esteem goes up, what should happen to my life satisfaction theoretically? What should happen? It should go up, right? And we're going to say, yeah. Now let's test that though. So you say, this is my research. I'm going to test this theory. I'm going to test it. Now look and see. Satisfaction is 13.653 because I have an optimism score of 19, a self-esteem score of 15. Watch and see what happens now if I take optimism to 25. Watch and see. Keep your eye on satisfaction, but now I'm going to go to optimism and change it to 25. You see what happened? It went up to 16.479. Suppose I say the self-esteem score is 32, high self-esteem. You see how my life satisfaction score changes? But do you see how the slopes here in green are what's driving my prediction? Does everybody see that? Does everybody see that? And does it make sense now? How we are going from something that looks like um, this to understanding how to predict my problem variable. This is what the weather folks are faced with. I have no idea what their predictive variables would be. Wind speed, temperature, dew point, all those types of things would probably be what's sitting over here in the predictive variable side. And as they change, we see how the total perceived stress would change based on this model that sits here. Now, the other important piece is something called the standardized coefficients. You have a unstandardized and a standardized. Now, we use this unstandardized coefficients, as you saw the slopes. We use those in the regression equation, okay? But we also have some other values. And let's take a look at the standardized coefficients to understand what those are. This standardized coefficient is saying that even though some of these variables can be on different metrics, let's say, for example, total self-esteem and age, those are different metrics. They're measured differently, right? But now, suppose I want to know the relative strength, the strongest predictor. But I can't judge that because they're different metrics. So what the statistics does is that it standardizes them and puts them on the same playing field and says the strongest predictor can be determined here by the absolute value. Which one of these is the strongest predictor in this model? By absolute value. Don't worry about the negative or the plus signs. What's the strongest predictor? Self-esteem. Self-esteem. Because the standardized coefficients tells you that. The unstandardized lets you know the rise or the fall. This lets you know the power of the specific coefficient. Makes sense. Now, all we have here are the 95% confidence intervals. Remember when we selected that? Now, let's look at that to make sure we understand what we're looking at. And it says that this is the 95% confidence intervals for B here, which is the unstandardized coefficients. And all it's saying is that we're never 100% sure in data analysis. But if we were to sample over and over again from the same data set and say you go in and you conduct this regression test 100 times using the same data set, that we are 95% sure, in other words, 95 out of 100 times, the true slope is going to be somewhere between a negative 0.574 and a negative 0.387. You see, it kind of gives us that range. In other words, the margin of error. So in other words, what we're saying is that it can be somewhere between here and somewhere between here. That's the concept of 95% confidence intervals. And I have some resources that I'll point you to that goes into depth with that. So does that make sense? You see how much now information that this output is giving us and helping us understand really now what's going on with the data, how the data is modeled? And you can't do a critical analysis and a synthesis. How can you do a literature review of quantitative research when you don't understand all this stuff that's going to undoubtedly be presented in that research article? You have to understand what is going on. Okay? Now, let's go into the next step and let's say, okay, so now how do we write that up? I'm not looking at research, Dr. Taylor. I've conducted it now. I went into my data set for my application. How do I write that up? I've taken the exact same output here. And now I'm going to show you here what it looks like when we write it up. So this can vary, but these are the main points here. But certain things such as this won't vary because this is going to come directly from the SPSS output, all of this stuff. And we're going to look at that, okay? So what are we saying here? We did multiple linear regression, and I did it to examine the relationship between, remember, self-esteem, life satisfaction, which is our model, a model consisting of two predictive variables. And what is this variable here? If you would put it into the chat, what would that variable be following the word and? What is that variable there? The dependent variable. Fantastic. Now, remember when we talked about briefly the analysis of the assumptions? Tell the reader that you did the preliminary analysis of these assumptions, and we're going to do the example of no violations were noted. And you can have appropriate figures there, and we'll look at that. Okay? Then you just simply go into the findings. The results of the multiple integration were significant. How do we know that? From, remember, the ANOVA table right here. But I've got a whole bunch of numbers here. So we know that the ANOVA creates an F statistic. That's right here. Okay, you stack F. You see the 2. You see the degrees of freedom of 2. You see the 428. You see the degrees of freedom of 428. Now, everyone on this call can now look at an output and fill in that information, but we want to take it a step further. What is a 2? What does 428 mean? Okay? Anyone want to take a stab at what the 2 might represent and what the 428 might represent? Okay. The number 2, fantastic. It is the degrees of freedom, but that, in layman's terms, is the number of predictive variables in your model. When you look at that output, you can now tell me there's a regression done and they had 2 predictive variables. I can already tell you that about this study. Anyone want to take a stab at the 428 here? Other very helpful information, I need some indication of the sample size. For multiple regression, the sample size is really the 428 plus the 2, which is 430. So we know that the sample size was 430. Does everybody see that? So right now, just by looking at F, 2 and 48, I can say multiple regression, 2 predictive variables, 430 samples. Do you see that? Already, just from that, I can turn that into English now. English that I can understand. Now, simply here, we're not going to get into mathematical statistics, but then what happens simply then is you report the F value, which just comes from right here, okay? Don't need to worry about that. The p-value, no problem, same thing. That comes from right here, okay? And you usually report 0.000 as less than 0.001, okay? The other piece is the R squared. That's the measure of the effect size, okay? Even though we have statistical significance, in most cases, it really doesn't give us any meaningful information, although we think so. Really, now what is the impact of that? I mean, what is the practical implication? In other words, the effect of that. So what this is saying 0.39. Where does that come from? R squared, 0.39. You see, I said R squared, 0.39 from the model summary. And then what that means is that if you were to take the 0.39, and you usually can make a statement like this in here also. And what you do is you take the 0.39, oh, excuse me, the 0.39, and you just move the decimal places 2 places to the right, and that's your percent of variance. So in other words, these two predictors account for 39% of the variance in total perceived stress. So basically, that's the measure of effect size. And you can either state that the R-squared value indicates that this model, you know, accounts for 39% of the variance. But the reader knows that once they, you don't have to put that in text, but you can, if you want to be that overachiever that you are. Okay? Are we making sense now? So now, an hour ago, if you read this in a study, would you understand that? Now, if you were to look at a multiple linear regression study now, would you have some kind of indication of what you're reading at without even looking at the abstract, without looking at anything? And if you know that it's a multiple linear regression test, you understand some things about it. And this is pretty much the point that I'm trying to drive home and where I've been trying to get you from A to Z, understanding the conditions that we use the test for. We need to assess assumptions. We assess them, then we run the analysis. Now, I'm going to be providing you with some additional resources. One of the things that I'm going to give you, and I'm going to put these into the chat, so make sure that we don't leave without me, is something here, an exemplar that I put together, okay? Multiple linear regression application exemplar. And what you'll have here, you can read all this stuff. And again, this is in raw format here. So again, I'm still working on this. But you'll see here, here's an example of research question. Is there a relationship between optimism, self-esteem, and satisfaction? And then I'm just saying, here's how null hypotheses would look. There's no, that would be there is no relationship. And then there is a relationship. But as you can see here, I've done the exact same thing that we just went through on the slide for a different example, okay? Now let's look at this example here, and you can see that all of this stuff changed here, okay? But now let's look at this. Was this a significant model? Let's just look at this. Was this a significant model? Can you tell me? You know nothing about the study, the research. Was this a significant model? Was it predicted? Yes, it was. What percent of the variance is accounted for by the two predictors? 30%. You see it's right there, the R squared. How many variables were in this model? What was the total sample size in this study? Bingo. See that? Experts. Now, remember when I talked about the strength of the predictor variables, how which one might have been stronger than the other? You see what I did here? I said both were significant. I'm going to highlight this in yellow. Both were significant, but I said self-esteem in the beta. Remember, that's that standardized coefficient providing a higher contribution than optimism. Remember, we compare them for the strength. Which one is the strongest? So 0.311 is just slightly higher than 0.309. But I'm giving the reader now some indication of the strength of each of the predictive variables and that both of them were significant. You might say, well, in the model, only one variable was significant. Okay, I don't know. And again, here's the regression formula, you see? And remember, these are all the slopes for the slope for the particular variables that again would align with the output here, you see? So I'm going to give you this document here also just to, as a resource tool, to help you. So now, what I'm going to do now is I want you to look in this coefficients down here in the bottom, okay? Now tell me, if my optimism score went up by 1 point, what would happen to my life satisfaction? Bingo, would increase by 0.471. Suppose my self-esteem score went up by 1 point. See that? That's what you're doing there. Were both of these variables significant contributors to the model? Which was the strongest contributor? Bingo. You are multiple linear regression experts. That's it, my friends, in a nutshell, on multiple linear regression. Now, does this make sense? Has it kind of clarified and eased the anxiety as we were trying to do? And the other thing is that you can do tables and figures in your output. And I just have an example of a descriptive statistics table. You know, the variables here, the n, the mean, and the standard deviation. And then you'll always have a regression summary table in your output. And notice these are the same components that are in the SPSS output. Remember? You simply just have to make this an APA table and then just transpose the numbers from the output to your table. So remember, this would be your slope that you would take right from the output, your standard error of your slope. Here's your unstandardized coefficient, etc. The significance value. And you would just simply be taking that information from a table here and putting it into an APA table. Does everybody understand that? And that's multiple linear regression in a nutshell in an hour or less. Okay? Now, what we've done here is we've done a quick revisit of the scales of measurement. Remember, when you get into that data set, you're going to be looking into that column, you know, for the measure of a particular variable and making sure that you use a scale variable for your multiple regression. We wouldn't use nominal, okay? Something like marital. We wouldn't use nominal because that's categorical, okay? Now, you can do multiple regression with categorical variables, but that's another session, okay? So that's why in the abstract for this, I said that we'll be using all continuous variables, okay? So now we did that. And then, so now we examine the conditions for using it. Remember, both of those variables are all, you know, the variables being scale in this particular example. We know we must test for data assumptions. We didn't do that here, but I'll show you something in just a second. We went through the procedures. We now know how to understand that output and to take that output and turn it into a write-up. Now, let's take a look at some quantitative resources. The first thing I'm going to point you to will be the ORD's website, the Office of Research and Doctoral Services, where I work. This is our website, okay? This is a scale of measurement, a more in-depth video tutorial on that. And here's a website called Lid Statistics on Multiple Linear Regression. But what I want to do now is I want to take you out to the Office of Research and Doctoral Services website, okay? That link that you'll have. And when you get that and go out to these resources, as you can see, you'll get a link. Remember, this is the session that we're doing here tonight. Tonight's session on the upcoming seminars, okay? You'll see that next Tuesday, I'm going to be doing one on hierarchical linear regression. And look at the abstract. It's the same as multiple linear regression, but suppose I want to control for variables. So you may be thinking in your research, I want to know what's the relationship between A, B, and C after I control for D. Well, this would be the session for you. But now, with those sessions that I set with the assumptions for multiple linear regression, go out here and take a look at this session that I did October of last year. That will go in depth with how you assess the assumptions, et cetera. Because if not, we will still have about another hour ahead of us here. And we know that's too much time, you know, for a training session. So That slide, I definitely want you to make sure that you focus on, okay? Now, Weird Statistics is a place that you can go out to the web, okay? I'm going to take you there now. Okay? And if you can see, it has a section on, multiple regression. And again, we want to predict that dependent variable, okay, from two or more other variables. Remember, it tells you to talk about the variance explained. Remember, we looked at that in our R-squared value. The model explains so much. Remember, we talked about the assumptions, interval or ratio. You need two or more independent variables. We talked about these other assumptions, okay? And then it even goes as far as an example, how the data is set up in SPSS, and even how to go through, again, analyze regression, linear, and the steps that you go through to conduct. Here in this case, there's, 1, 2, 3, 4 predictive variables in here, you see? So this is a model of 4 predictors. But anyway, let's take a look at this. In this example, was this a significant model? Were these variables able to predict the dependent variable, which is oxygen maximum output of something? Did gender, age, heart rate, and weight, were they significant predictors of the dependent variable? Yes or no? Did this model significantly predict that dependent variable? You see that? You're looking at something now and you're able to discern what this means. Remember, we don't know anything about the specific predictors, but now look at the coefficients. Were all of these variables in this model significant? Were all of them significant? Yes, they were. Which variable provided the most strength, the strongest predictor? Gender, exactly. Remember, you look into the standardized coefficients, that's the highest absolute value. Okay? Now, this is a good example to close on. This is a categorical variable here, gender, male or female. So in SPSS, think about it now. You would code, say, for example, male is 0 and say female is 1. Okay, think about it. Male is 0, female is 1. So what we're saying is going from a 0 to a 1. Remember that 1 unit increase, the score on the dependent variable will go up by 13.2 points. So we're basically saying a female would have a 13.208 higher oxygen output than a male. Does everybody see that when we're talking about a categorical variable? It depends on how we coded it in SPSS. 0, 1, 2, 3, 4. So that's a great example of a categorical variable. But here, these are all the scale numerical variables, age, weight. So as one gets older, what happens to their oxygen intake? Tell me, as one gets older, 1 year older, what it lowers by how much? Bingo. You see that? There you go. There you go. That's it. Okay. So now let's do something before time runs out. Let's get the presentation and all these things into the chat. So bear with me now. Where's that chat at? So let me put the presentation in here first. Okay, presentation. Okay, you should see a bivariate regression exemplar. That's going to be a Word document in there. Now I'm going to put the presentation in there, okay? Okay, now check at the very bottom of the chat. There should be the PowerPoint presentation. Okay, does everybody see that? And then I'll put a copy. Now, if you find any errors or anything in this, typos, please bring that to my attention because I've been, really trying to put this together very quickly and give you as much as possible. But you get the gist of everything here that we tried to accomplish. So the another one, that's the exemplar. That's the exemplar. Yeah. So yeah, that should be everything there that'll get you going. Again, the last slide will take you to the links for the ORD's website. Well, you see a host of. Now the other thing is that what I wanted to do is take you to the ORD's website, and when you are in your proposal stage, I saw some individuals, or one or two names individually were indicating they were doing the proposal stage, and you can get support from my office. And for example, you can schedule, for example, this is for individuals that are working on their proposal, okay? And we help you with the research design alignment. And you can schedule an appointment here, click on that link, and you'll see that all of the methodologies are listed. Make sure you don't select someone qualitative. If you're not looking for a qualitative, you would click, say, on the person's name. You would see the open appointments, and you would continue and click and schedule an appointment. And we work with you through your research design alignment, making sure your gap, your problem, your purpose, your research questions, and the analysis are all well aligned, and that you have the foundation for a feasible and doable study, so that there's no really, really egregious errors in the very beginning that's going to send you back to the drawing board. As a matter of fact, I had a team meeting today, and in the past 3 years, we have done over 5,000 of these individualized appointments that have helped students navigate through the quantitative journey. Okay, so take advantage of these resources. They are there. Okay, so that's all that I have. The other thing is that I would really strongly appreciate if you would go out to the survey and tell us what you thought about this. What drives this is what I get in those surveys. Do you need more? Do you need less? Do you don't want this? What else do you want? Am I hitting the mark? Is it too much? Is it too less? Really need to know, because I really, and I know you hear this everywhere you go, I really use this feedback to develop these sessions. I do. This is my project. I do this alone, and I look at this and I really use that feedback to help you out. Okay. So other than that, that's all that I have. Again, and I'm hoping, and again, let's get a final comment in the chat, or at least if you want to put more. Did we ease anxiety here this evening? Fantastic. Fantastic. All righty. Well, I've met my objective. Okay, so now I'm going to stop sharing. Now, what's going to happen? Remember, when you go out to the ORD's website, hopefully by tomorrow morning, you will see that this video has been put into, let me go to that website again. This recording has been put into the ORD's website area right down here on on-demand quantitative seminars. The top one should be what we did tonight, the multiple linear regression session. Okay, does everybody understand that? The one we did tonight should show up here, and you'll click on a link and it'll take you to the recording for this session. Does that make sense? Everybody okay with that? Okay, well, thank you. If you find the time and need to, you're thinking about, okay, I would like to take my knowledge in multiple regression, but extend it to perhaps that I want to control for some variables, that session next week is suited for you. Again, I wish you continued success on your quantitative journey, and you know how to reach me and schedule an appointment at the time needed. So again, I thank you for your time. I'm going to stop the sharing now, and I'm basically going to just exit now, and I'll leave the chat on in the classroom for a few minutes if you still need to grab some of those documents out of the classroom, okay? So thank you very much for your attendance. I really appreciate it, and hopefully you've got some great benefit from this session and many more to come, and those that have already been pre-recorded for you. Thank you very much.